All right, hello everybody. Welcome to our webinar today on low impact laundry. My name is Brian Stewart from Electrify Now. I'm joined with Joe Wachunas from Electrify Now and Pramod, who's been helping us out here with this project, and Christopher Diamond from NIA that we'll introduce a little bit more formally in a bit. I just want to give you a little background in case you're not familiar with us. Electrify Now, we're a voluntary organization. Our whole purpose is to help to empower people to create the clean energy future by the energy decisions they make in their own homes and their own lives. And we advocate that people clean up their electric supply, then look around your home and see all the gas burning devices you have, gas and fossil fuel burning devices, and transition those to electric options, and same with transportation. And doing that will make you comfortable, potentially save you money, and absolutely reduce your carbon impact by huge amounts. A typical home is about 20 tons. And then we have to make sure we bring everybody along with us. We call that Electrify Everyone, to make sure we don't leave people behind in this transition. There's tons of information on our website, electrifynow.net, if you want to find out more. I want to also give a shout out to our coalition. We have over 40 members now who are all kind of like-minded organizations who are committed to promoting and advancing electrification. We have members of almost every type of organization here. And if this is something you might be interested in and you want to talk to us about joining the coalition, please let us know. Coalition also really helps to provide content for our webinars. And one of our coalition members is Community Energy Project, and we do a lot of work with them around this program we call the Electrify Everyone Fund. And it gets back to that point we were talking about in terms of bringing everybody along with us. And thank you for all of you who might have made a donation for this webinar. We really appreciate that. And we've collected a lot of money partly through these webinars and through voluntary donations from corporations and individuals. And so far, we've installed about 50 heat pump water heaters through this program in low-income households. We get take out an old gas water heater, put in a free heat pump water heater. It saves these families, a lot of money over the lifetime of the product, and avoids about 25 tons of carbon. So really cool program that's an example of bringing everybody along with us. Some of these people have a hard time electrifying without some help. I also want to give a little shout out to some of the upcoming webinars we have. In September, we're going to be really examining the role of natural gas in the future of our electric supply, our energy supply. And we want to talk about all the things that are, the real and not so real potentials of gas in our future. And then we're also going to be focusing on 5 webinars around building electrification as part of Sustainable Building Week in October. So we'll have more information about both these things on our Eventbrite page. Check them out and tune in if it works for you. All right, Pramod, maybe tell us a little bit about Hang Dry Week.
Thanks, Brian. Like Brian said, we're actually right in the middle of Hang Dry Week 2021. So this is a social media campaign that Joe has helped started, and it's been going on since 2019, if I believe. 2019. So so really easy to participate. Step 1 would be hang dry your laundry, and step 2, can I see the next slide? Perfect. Follow us on Instagram at Hang Dry Week and take a picture of your laundry. And if you tag it with the hashtag, at the end of the week, we're going to go through and find people who participated, and you could win some great prizes. For example, Spin Laundry Lounge, which is a sustainable laundromat here in Portland. We're giving away gift cards for them. We're giving away tickets to Solar Oregon's Go Zero tour, which is a tour of zero energy homes here in Portland. And we have some other laundry supplies, such as a drying rack and detergent strips. So a lot of fun stuff. So if you want to win some prizes, take a picture of your laundry, make sure you tag it with the hashtag Hang Dry Week, and we'll see who wins. So Brian, why are we talking about laundry this week?
Well, actually, Joe's going to take this part. And Joe, I can see you got I like the props you got going in your background
Yeah,
there.
I hope everyone can see we're practicing what we preach here today at Electrify Now. And with that, a little disclaimer that you may hear airplanes or hopefully not a leaf blower, but we're coming to you live from my backyard with my laundry behind me. Yeah, so why are we talking about laundry? We like to set the context and the stage every time we do a webinar, and this one maybe deserves a little more explanation. Instead of water heaters and EVs, we're talking about laundry, something so quotidian as laundry. Why talk about it? Well, to help answer that question, let's talk about the electrification of everything. A lot of folks, us included, think that electrifying everything is the quickest way to reduce our carbon emissions. And in order to do that, we're going to need to triple our current electricity supply, according to a lot of experts. So, over here on the left, we have all the loads we use electricity for now, our hair dryers and you're charging your computer, all that electricity, we're going to need to double it just to get to electrify all transportation. Recently just came out that 2.5% of new car sales in the US are EVs. We got to get that other 97.5% to electric, and we're going to need to double our electric supply to do that. And then to electrify buildings, we're going to need to do the same thing. We're going to need to double our current electric supply to provide electricity to all our buildings. And additionally, there's one more wrinkle in the challenge where you have to provide that electricity with renewables, with solar and wind. So, a big task is ahead of us. And the one thing, we really are excited about, a big help for us in this challenge, is that a lot of the new electric technologies are so much more efficient than the old ones, which is something we are trying to hammer that message home, every month and every webinar. So you look at your electric resistance water heater, and it uses 4,000 kilowatt hours a year on average. Well, the heat pump water heater, without any difference in quality, you're going to use a quarter of that, 1,000 kilowatt hours a year. Similarly, if you use that old electric resistance heat, it's a ton of energy, 12,000 kilowatt hours a year, and you use a third of that for your heat pumps. Don't miss our heat pump webinar, which we did in July. Electric dryers that we're going to be talking about today, and Christopher is going to be talking about, 1,000 kilowatt hours a year, you can save 60% of that and get to 400. So a way to really reduce your usage. And just to put it again in a little bit of context, Europe on average, just to give you a number, they use 3,700 kilowatt hours a year of electricity. I think a lot of us who've been lucky enough to go to Europe know that they're living pretty well over there, and they're living well efficiently, using 1/3 the electricity of the average American household. Now, there's a lot of reasons for that, bigger homes in America, what have you. But one reason is laundry. And we're going to see today that, by this simple quotidian practice, if we reimagine it a little bit, we can really take a chunk out of that and live more efficiently and better for ourselves and the climate. So with that, I'm going to turn it over to our first panelist, Christopher Diamond, who is a senior product manager at NEA, the Northwest Energy Efficiency Alliance. Chris is responsible for identifying new market transformation opportunities by determining the energy and demand response potential, the market barriers, the opportunities to change the market, and the leverage points that affect that change. He focuses on variable speed heat pumps, something near to our hearts, but he led a lot of the NEA's research on really efficient washers and dryers, which he'll be talking about today. So he's the perfect panelist to have. Today he has his undergraduate degree in physics and engineering and a master's degree in building systems engineering with 25 years of experience. And then I'll be joining right after, quickly talking a little bit about hang drying. I'm a program manager at Forth, working on transportation electrification. My lucky turn in life is that I went to Italy as an exchange student, was captivated by the fact that so many Italians hang dry their laundry. And so I'll be talking about that a little bit later. So put your questions in the chat, or excuse me, in the Q&A if you could, and I'm going to stop sharing my screen and pass the mic to Christopher.
Great, okay. Let me fire up the, okay. Can you hear me?
Yep.
Okay, so I've got a bunch to share with you. And principally, I'm going to share a little bit about, the energy use of clothes dryers and what kind of spurred NEA to look at this at all. And talk a little bit about the research we've done over the last couple of years around principally heat pump clothes dryers and the test procedures that we did develop. And then I'm going to talk a little bit about some recommendations around the technology, the buying, and the operating to maximize your energy efficiency. So it's about a decade ago, we started asking our question, why has it been that the energy use of the refrigerator, dishwasher, and clothes washer of the 1980s got so much more energy efficient, but the energy use of clothes drying really hadn't changed. In fact, the only difference between the 1981 and the 2012 machines was because the washing machine was doing a little bit better job at wringing out the water. The dryer was no more efficient. And at kind of a macro level, like Joe said, that, there's about 1,000 kilowatt hours, maybe plus or minus, depending on how wet your clothing is and whether or not you have a top loader or a front loader washing machine. But I think it's kind of useful to know about washing, actually, the mechanical washing and the moving of clothing. It doesn't use much energy at all. The water heating that some people are using to in their clothes washing uses a fair bit. And you don't really need to use hot water. You can use cold water detergent and do just fine. But the real big one is the way we've dried clothing in the US is that we use heat to actually vaporize what remaining moisture is on the clothing. And that's pretty energetic. So we started asking ourselves, what's out there? And started looking to what was being done in Europe and Asia. And they were using heat pumps. So what is a heat pump dryer? Effectively, what you've done is you've coupled a dehumidifier with a clothes dryer. And so instead of just adding lots of heat and boiling off the water, essentially, what you're doing is you're injecting warm, dry air into the drum, and the clothing is bouncing around. It's then transferred across a cold coil where moisture is condensed, so that warm, wet air is condensed out to water. Water is drained out through a little tube, the same location where your drain is for your clothes washer. That air is then circulated back across the hot side of the condenser of this. It's essentially a little heat pump going on in here, just like an air conditioner or a dehumidifier. And that air is then becomes dry and warm, and it's put back into the clothing. So it's a completely closed cycle. And one of the nice things about doing this is that you're able to drop the temperature the clothing is experiencing as it's doing all this and still extract lots and lots of moisture from them, just like any kind of a dehumidifier. And technologically, it's not a big hurdle. You can buy a little window air conditioner, which is essentially a form of this, for what, $150. So we were thinking this is possible. This is something that could be added to a conventional dryer, and we could end up with a dramatically lower energy use. And the reason is because it's a lot easier to move heat than it is to actually just inject it into a space and boil off the water. This is energetically going to use about half the energy of an electric heater. And in the market today, there are a variety of mostly European, some Asian, heat pump clothes dryers. And most of them are these little compact size, but they're not compact capacity. They are full 8 kilogram, 16, 17 pound capable machines. They'll hold the same weight per their specifications as the bigger ones. And the more common US model is 27 inches wide, and the European, they're more commonly 24 inches. And these come in both a pure heat pump variety or what's called a hybrid, which means they've got a little bit of that electric heater to kind of kick the cycle going and the heat pump. So it's intended to kind of be the best of both worlds. And I'll talk a little bit about whether or not it succeeds in doing that. So as we kind of dove into this, we started, okay, how do we know which ones to go after? We wanted to first just understand, how do they use their clothing? What do they do? So we did a field study back in 2012 where we paid 50 families to weigh their clothing, write down on a little board, what setting did they use? How much did the clothing weigh before it went into the washer? How much after the washer? And how much after the dryer? What cycle settings they used? And any other kind of detail. Along with that, an energy meter so we could actually monitor the amount of energy use. And this was really transformative because it kind of showed us something important, which is that when you look at how people use their dryers, the amount of clothing they put in the dryer ranges enormously from just a few pounds to, I don't know, how do you fit 24 pounds of clothing into a dryer? It's very heavy clothing, I suppose. And the moisture that comes from the washing machine should be largely removed. You should have 60% or 50% of the weight of the clothing be in the moisture. So that is to say, if you had a pound of clothing, you should have half a pound of water. But what we're really finding is that there are a lot of machines, washing machines, that don't do a very good job of wringing out the water. And you look at the scale here on the vertical side, some of the clothing that we were testing, people were probably picking up clothing out of their washing machine that was wet enough that they could just squeeze it and water would come out. And the other thing to take away from this is that the test procedure that we use, that we evaluate all of how well we're doing, that estimate of how much energy use and everything, that's all based on a federal test procedure that really is only looking at a tiny fraction of how people use their machines. So that got us to kind of head down the next path of, well, tell us more a little bit about this test procedure, because if you're trying to change how people choose what they do and change how manufacturers build, one of the most effective things you can do is make sure that the information you provide consumers and the requirements you place on manufacturers is consistent with real world. And what we found was that the federal test procedure evaluates under conditions that people rarely use. Second thing is that it doesn't actually use real clothing. The test procedure actually uses these 24-inch by 36-inch, very thin, 50% polyester fabric samples. It's a very controlled, very precisely, gives you very repeatable results. But it doesn't really reflect how people use their dryers. And so what we did was we developed a supplemental test of real clothing in a couple of different sizes and settings for the machine so that we could get a better understanding of how are these doing. And this graph on the x-axis shows the amount of pounds you can dry per kilowatt hour you spend. So if you use the DOE test, the D2 test as it's known, we tested lots of machines. We tested heat pumps, hybrids, Energy Star, conventional, and we used these different types of tests to see how they compare. And the Energy Star machine, let's just take a look at that one. Yeah, you get about 4 pounds of clothing dried per kilowatt hour, 4 pounds of the DOE test cloth. But consider if I actually did the same with a small load and real clothing. So this is the small real clothing bar graph. I can barely get 2. So just by choosing how much clothing you put into the dryer and the fact that you went from 50% polyester napkins to a blend of real clothing, you got half as efficient. This is sort of an aha, like if you're thinking about trying to tell people how to dry and what machines to choose, what it really starts to indicate is that, we need to understand how real clothing impacts performance and how load size. The more you fill the drum, the more efficient it is at removing moisture. There's more contact time, the more flipping and little air. It's not just all the air rushing out through the dryer without first grabbing as much moisture as it can. So that was pretty insightful, actually, sort of understanding this, coming up with a metric so that we could evaluate the best of the best with something that really represented real world. So we created this blended metric, and that's the one we're using for evaluating. But we then had to do some field evaluations just to see, okay, how do these machines really do in the real world? And so we did basically 28 washer dryer sets in 28 homes and had people once again weigh the clothing before, middle, after, measure the energy use, And we looked at the hybrid machines, which are kind of the orange and yellow dots, how energy efficient they are. The higher on the scale, the more energy efficient. And the bottom axis, the x-axis, is how heavy the load was that they used. So a typical load size is around 8.5 pounds. That's the average. But you can see there's a huge range. And people with the compact dryers, the blue dots, they were, on average, not quite loading them as full. People aren't used to stuffing their dryers. And there is one disadvantage with stuffing a dryer, is it will take longer to dry. It's more efficient, but it takes longer. And I think a lot of people don't think they equate how long the dryer runs to how much energy it uses. And if you have a very efficient cycle, then you actually don't mind it running a long time if the actual mechanics of getting the moisture off the clothing is more efficient. So oddly enough, a fuller dryer is going to be more energy efficient. It will take longer though. All right, so we got some initial studies that really kind of showed us, wow, look at how much more efficient these heat pumps are. They are twice as efficient. And then we said, okay, well, let's combine that with a washing machine and look at how much energy does the washing machine and the dryer use together, because they really are a pair. And this is going to be on this graph, where on the x-axis, same thing. It's the weight of the clothing, but on the y-axis, it's the total energy of the washing and the drying. So in this case, the higher up the higher you are on the scale here, the more energy you use, and the lower down here, the blue dots, the more energy efficient. And you see here that the conventional washing dryer machines, what they suffer from is their washing machines were not extracting much water. But the hybrid machines did a good job of combining a really good washing machine, a front-loading, high-speed spinning washing machine, with a good dryer, a really good dryer. And the blue dots are once again about half as much energy. So it's kind of like at the maximum limit of everything you could do. So when we compare the amount of savings we got compared to the reference case, this is what this graph shows. And once again, we're kind of thinking about the washing takes 50 kilowatt hours, the water heating per year, maybe 150, the drying somewhere in the order of 800. So we got about 1,000. So out of 1,000, this is how much savings you're getting and where you're getting it from. And for the European, this case was the Blomberg unit, but a lot of those European heat pump dryers and the compact heat pump ventless dryers, you're getting enormous savings from the dryer. The washing machine could be more efficient, of course, could spin out maybe a little faster, but the reality is all the work is being done by the dryer. So the savings came mostly from the washer. It's sort of this trade-off of where do you get the savings from? And in the end of the day, these hybrids only saved about 200 compared to 300 kilowatt hours for the heat pump dryer. But what we're really interested in, again, is the matched pair. Compared to, a conventional washer and dryer pair. Pretty good savings, really. So a couple of things about these machines as we're kind of going through them. We looked at how much time does it take to dry the clothing? Because when you use a heat pump, it's at a lower temperature. It's using a dehumidifier. And so in the field tests we did, we saw, 30 to 50% more time, 30 minutes was sort of the Blomberg heat pump dryer, the compact heat pump dryer. The hybrids, they were using a little more time, but not a whole lot, not statistically very much. Minnesota did a similar study, and they saw that this is I don't understand quite all the details, but they saw similarly that the pure play heat pump dryers could take on the order of, looks like 50 minutes, in that kind of range, more time. But I don't know what their conventional dryer was and whether or not their conventional dryer was matched to a good washing machine. And that's really the challenge here, is that if you put a heat pump clothes dryer with a really, really poor washing machine, you would have a very bad experience because you've just put a lot of wet clothing in something that takes a long time, doubling and tripling the amount of time it takes to dry. If you have a very efficient washing machine that spins the clothing down to 40 to 50% relative humidity, remaining moisture content, then the dryer doesn't take very long. So that's kind of what this is showing. In both of these two field studies, both by NIA and Minnesota CEE, satisfaction was really quite high. In fact, the only areas where I think it's worth pointing out is the time to dry was less satisfactory. Otherwise, all the other kind of general indicators that we saw when we did our evaluation and they did with theirs, people preferred the heat pump machine for its features, the way the clothing feels, the gentleness on the clothing. Then we also did a detailed look at kind of what is the added cost. And I want to show this graph and explain it to you. It's a little complicated because the cost of a clothes dryer really depends more on the other features you're getting. And you want a glass window so you can see your clothing tumble. I know all of you just sit around watching the clothing tumble. That's going to cost you a little more than $120 extra. You want it in a non-white color? Do you want it to be pink or blue or red? That'll cost you another $100. Do you want it to be a little bigger? Remember, just volume. It doesn't mean it doesn't hold more clothing. It just means it looks bigger. And yeah, I know bigger looks better, but trust me, it's not. Do you want it in stainless steel? Do you want to have steam injection? Do you want it to be stackable? All these things end up with being a lot more of an impact than the detail of whether or not it's Energy Star or not. So the incremental cost of these machines is for an Energy Star, on the order of $100. For a heat pump machine, kind of depends on where you first choose your features. If you choose, I want all the high-end features, then the incremental cost is not much. If you want to compare it to a base model with none of these features, the incremental cost, the additional cost of a heat pump dryer is a lot. It's $500 or $600 potentially. So one of the last things we did in our studies was we looked at, do these things actually, are they gentler on your clothing? Because I kept saying, if I could show that it could just extend the life of your clothing by the equivalent of one polo shirt per year, it could pay for itself. And so we did rounds and rounds and rounds of drying through cycles of different machines. And we had paid people to come in and touch the clothing and rank them and all double blind, all this high-end research stuff. We even used these strain gauges to tear the clothing apart to find out which one tore easily. The bottom line was that there really wasn't any statistical difference. All the damage done to the fibers in the clothing is really done in the washing machine, not in the dryer. The dryer is where the lint comes out, but the lint is being broken in the action of either day-to-day wear, or if you put it in a washing machine, especially those with the vertical axis, the old agitators, they're really good at breaking clothing fibers. So we didn't find the polo shirt with the savings that I was hoping for. NIA continues to test all US sold heat pump clothes dryers. We maintain a list and we'll provide that to everybody. The other source of good dryer information is Energy Star maintains a database, and you can go and find that. Our little list also includes kind of how much savings relative to each other you might find. And we don't rank anything that's not above Energy Star. So Energy Star will save you above an average market average machine. So if you're going out to buy a new one today, a lot of the dryers have already almost caught up to where Energy Star is. So the incremental savings is pretty small. You get a big change when you start going to a heat pump. So let's see, some just sort of summary notes, if you will, and I'm almost done. These are well-established technologies. The company that I showed you the data for, little blue dots, Blomberg or Beko, as it's called today, they build 11,000 units per day in their factory in Turkey. They meet the entire US market need for their product sales in 1 or 2 days. So they change their factory over, run the US model, and then they don't come back until 6 months later and they do it one more time. So they're making millions of these things. It's very well established. They're on their 7th generation machines by now. They're going to save 20 to 60%, about $20 to $120 a year. Not a huge dollar saver. They are going to take 20 to 40 minutes extra per cycle. They're slightly gentler, but not statistically significant. One of the things, though, that is perhaps hard to quantify, and I kind of refrain from like making too much of an issue of it, is one of the most common sources of household fires are laundry fires generated by gas or electric. Ignition of the clothing fibers, why you should clean out your lint. It's you're putting a red hot element or a flame right there, dried powdered clothing. But with a heat pump, it never gets that warm. It's just not possible to get that level of heat. Another thing I think it's worth pointing out is that they're really good for heating climates like the Northwest, because if you have them inside and they're ventless, they do use energy, and that energy is going to actually warm up your house in the wintertime, in the fall, and the spring. It's not going to benefit you too much in the summer, but if you're in a hot, humid climate, you want to have one that's vented. You don't want to have a ventless machine, because you're already trying to fight the battle of keeping the humidity out of your house, and to add a dryer that's going to add a little heat to your house, probably not. It's at least ventless. There are vented versions of these products as well. That would be fine. And yeah, they cost anywhere from $100 to $400 more, depending on what kind of features you're choosing. So that's it. That's the general comments I have about the heat pump dryers. When you're considering to buy them, well, I think I've already said this, 5 times? Buy a matched pair. If you don't, you're going to be sorry. You get more energy savings and you're going to reduce your drying time. When you're installing these things, you got to remember the dryer is going to actually dribble a little water out of its drain tube, and that's got to be put to the drain. Quite a few of the systems we had installed, the homeowners immediately called us up and all upset because there was a pool of water pouring out from underneath their dryer. The installer had no idea that you were supposed to hook up this little hose. It's very easy. It's just a little half-inch hose, and it just goes right down the same spot to your clothes washer drain is, but you got to put it in. If you have a ventless, you can plug the hole in the wall. There's no need to have that added ventilation loss to your house. And if you're doing a lot of laundry, the compact heat pump dryer, or just the heat pump dryer in general, might not be the best option, because it is going to take longer, especially if you want to do a lot of back-to-back loads. Some people who are sort of time constrained, it's something to be aware of. Big families, people are doing 3 or more loads a day, probably want to go to a full size. One of the interesting things that is maybe secondary to, maybe only interesting to this group, is it because you're actually using so much less power. They only draw 1,000 watts or 1,500 watts instead of 7,000 or 8,000 watts. Your electrical panel, that 7,000 or 8,000 watts is about enough to charge an electric vehicle. So you can actually take the dryer, the place where the dryer plugged in, and use that then for an electric vehicle charger potentially, and dedicate a more common circuit to the heat pump dryer. Lastly, I got some operational recommendations. Full loads, yep, definitely use less energy per pound than small loads. Front loaders, front load washing machines I'm referring to. Clean as well and use less water. Cold water, using modern cold water detergents is just as effective, plenty of studies on this, as warm water with warm water detergent. And these 24-inch wide, they look small, but they're actually fully capable machines that can handle the weight. And you can kind of be a judge of how full you want to stuff it. I can't get my mom to load her front loader because she's like, well, the water only goes up to this little level. I was like, no, really. It's like having a shower on your clothing rather than a bathtub. You'll get cleaner. All right, so that's it. Let me hand it back over to Parmud and team.
Thanks, Chris. Hey, while we're switching over, we got Pramod's done a little bit of research onto popular models and costs and things. Pramod, you want to walk us through this? What did you find out?
Sure. So first off, I wanted to echo what Christopher was saying about the Energy Star rankings and their testing of dryers. And there's the link on the slides, but I also just put a link in the chat to Energy Star's most efficient dryers of 2021. And every single dryer that made their list was a heat pump dryer. And they tested the whole range of like gas, electric, and heat pump. So only the heat pumps made the list, which is definitely something to take note of. So I included these 4 brands. There's like a wide range of budgets. There's 13 dryers on the list that vary in price between all of these, but they all essentially they look very similar, but they all essentially do the same thing with the same technology. Some have better scores than others. I wanted to point out that Christopher mentioned Blomberg as one of the brands, and there are 2 Blomberg dryers on this list.
And they're now sold as Beko.
Okay, they're also sold as Beko. Got it. We have a question in the chat asking if all heat pump dryers are ventless. I believe the answer is yes. Christopher, feel free to correct me on that.
When we did the study, there were some of both, but I think that they've switched more and more to just ventless. The advantages are pretty clear. They're great for an apartment building where you don't necessarily want to have a vent or even service event every year.
Just on the cost side, so Christopher, you were saying that you could potentially be saving, $20 to $120 a year in energy costs, and if the unit costs, maybe $400 more than a conventional dryer. I mean, it seems like you're going to get your money back basically over the lifetime of the dryer. Isn't that true?
Yeah, you'll get your money back. If that's your motivation, go for it.
Yeah. The other question I had was about one of the questions in the chat was about the plugs and loads. So you were mentioning that there's a lot less of wattage that's required, but are these running on 240 volt circuits or 120?
Yeah, they're going to be 240. The ampacity of them is much, much lower. So I've owned both the Whirlpool hybrid, and I currently, for the last 4 years, have had the Beko Arçelik Blomberg variety from Turkey. And you plug in one machine into the 240 volt outlet, and the other machine plugs into it. So you literally you're it only draws up. It's freeing up a circuit, but it is a 240 volt circuit in this case. So.
Gotcha. So otherwise, I mean, you use your current, if you have a current dryer and you just replaced it with a heat pump and you plugged into that circuit.
Yeah. So the circuit is designed to be 50 amps and I'm drawing 12.
Right. Okay. Great. There was another question about whether there are these hybrid machines that are a single unit for washing and drying, because that occurs in conventional equipment. Is it possible to get a single unit that's a washer and a heat pump dryer?
There is. I never did any deep investigation to that because you've just changed the cycle time from being able to do both of the machines at the same time to it's one load all the way through. They're generally more of a space constraint product. So if you've got an extreme space constraint, you do that. They don't save, as I recall. They're not a whole. I don't think they're really any cheaper than buying a pair. I honestly don't know that much about them, to be perfectly frank.
Well, we had another question about wrinkles. Any subjective difference from a wrinkle standpoint between a heat pump dryer and a conventional dryer?
No, in our fabric testing, the general comment was that they liked the feel of the heat pump dried clothing better. But one of the downsides of having, if you overstuff your dryer, is you can introduce more wrinkles, especially, if the clothing sits after it's done in its cycle. So wrinkling is some of the machines today combat that by injecting steam or throwing on an additional tumble cycle at the very end. Even my machine currently, if it's sitting for more than 15 minutes, it turns on and just churns the clothing for 15 seconds or so. And that's to avoid that kind of wrinkle.
Hey, Christopher, a couple things that stood out from your fantastic presentation. I just wanted to highlight that the most of the damage in like washing clothes occurs in top loading washing machines. Maybe that's something you want to emphasize to folks, that front loaders do less damage to clothes.
Yeah, and it's like some of the top loaders now have a non-agitator. They don't have an agitator in the middle. Those are the more energy efficient variety typically. We didn't have any kind of look at that. That would sort of, based on the mechanics of it, seem to use less agitation and yes, less colliding of clothing than an agitator that's doing that kind of churning motion. But yeah, that's sadly we didn't find what I was hoping would be the silver bullet to get everybody to want to buy a heat pump dryer, was if they were actually that much gentler to clothing. It's not because of the dryer, it's because of the washer and the general wear and tear you might get during the daytime. But
you found in the surveys that people really, except for the little bit longer,
slightly preferred the feel and touch of the heat pump clothed dried samples. Yeah.
Perfect.
These are all coming down to somewhat subjective, outcomes. So as best as we could, we didn't find any like holy grail of they're wonderful to clothing. Most of the modern clothes washers and dryers are actually trying to achieve that really nice, easy to your clothing.
Christopher, there's a few questions in the chat that are about specific models of dryer or recommended models. And I know we're not going to have time to go into that today, but are there resources on your NIA website that would talk about this model versus that? Or the Energy Star ratings are going to give you some information about energy performance, but is there any other qualitative sources of like what's a good dryer get in this zone?
I would probably turn to someone like Consumer Reports that does the kind of consumer facing kind of experience. NIA is very much like, how do we change the market without the consumer ever seeing it? So we don't really have anything consumer facing. It's utility facing and contractor facing. We're kind of the ghost in the machine when it comes to energy efficiency.
Yeah, that's a good suggestion. I'm sure Consumer Reports has done some. We'll try to see if we can find a link for people to send out in the notes with when we send a wrap up to folks, with if we can find a good article on qualitative information about the different options.
One thing I will say though is that the savings numbers you're going to find at Energy Star for the compact dryers are based on the federal standard, and the federal standard splits anything smaller than 4.4 cubic feet, which is all of these machines, into a subset where they're assumed to be very small amounts of loads, very small amount of clothing. So when they show savings numbers on the little orange label, the savings don't look very big. And that's because they're using the DOE test and they're assuming that you're only drying, I think it is 800 pounds a year, not the 2,500 pounds a year that most families use, 2,300 pounds a year. So keep in mind that Energy Star is required to use federal test procedures, whereas NIA is not. We can come up with our own, validate them, and do that. And that's why we did that, was we wanted to provide the market with, and utilities specifically, with information that they could be the basis of their incentives or programs.
Great. Hey, we should probably move on. I think we got to have turn over to Joe for his part of the presentation. But thanks so much, Christopher and Pramod, for that.
Yeah,
Pleasure.
So we will have, I'll be quick on the hang drying part, and then we're going to have a little more time at the end for Q&A. So please keep putting those questions in the chat and Q&A. So let's turn to the other mode of drying your laundry efficiently, other than heat pump dryers, hang drying laundry, or as we like to say, fighting climate change with your undies. Why do we need to have a webinar or a presentation on hang drying laundry? It's one of the easiest things that you can do. You take a clothespin or just hang your wet clothing over a line, and voila, the sun, you get to harness that solar energy. But because, we're going to see that in North America, we've kind of gotten out of the habit of clothes drying, but maybe we need a little primer on what the rest of the world is doing. Quick little background. I think a lot of us, this is my grandma on the bottom right, a lot of our grandparents and parents were hang drying laundry. My grandma in the 1950s. Here's my dad in the 1980s. Dad's on the webinar. Hey, Dad. And I have memories of running through the backyard, playing in these laundry lines. But it wasn't, hang drying didn't become like a fascination for me until I went to Italy, and I saw that in the 8th largest economy of the world, only 3% of households have dryers. Every house, every season, every sort of belief system, this is just a given that you hang dry your laundry everywhere. And I was kind of captivated by this, an industrial country that's hang drying. And as I've looked into it over the years, it's not just Italy or just Europe. All over the world, folks are hang drying. Here's Russia, where folks are, this Siberia, where they're freezing their clothes dry in the winter, and the ice forms on it, and then it sublimates, goes directly from a solid to a gas. Here's China, a really advancing economy, very technologically savvy, but dryers are just not bought and sold. I'll put a Washington Post article in the chat, saying that Chinese on the whole are just not interested in this technology. They believe the sun does a better job, the UV rays disinfect clothing, and as you can see, they just use the sun to dry their clothes. Here we are in Ghana, where I had the pleasure to travel. Here we have some lay drying clothes. And I think for a lot of folks, the dryer's not even on the radar screen. They don't have the option to afford such an expensive piece of equipment and don't want it and get along well without it. So both industrial countries and not, and large economies and not, this is my back of the envelope. I've done some Google searching on percentages of hang dry usage, not nearly as thorough as NIA's study. So please take this with a grain of salt. But you just get an idea that besides North America, with the United States and Canada, everyone else is using the dryer vastly lower than us, lower than 50%, some just not even using it at all. So the world is really hang drying their laundry. And why are they doing that? Well, I think the first answer is it's just interwoven into culture, and it was in our culture as well too, not too long ago. And so folks, just see their neighbors doing it. It's just what you do. They have the hang drying technologies at their fingertips. You might hear some cars passing. This is live webinar. So you can see in the top, it's Japan. Folks hang drying their laundry. In the bottom left, it's Brazil, and on the right, it's of course of Italy. It's just what everyone does. And so I always just find it fascinating that, in the United States, I run in environmental circles, and most folks do not hang dry their laundry, even diehard environmentalists. But in Europe, everyone I know across every spectrum hang dries their laundry. It boggles their mind that North Americans don't. And so another reason I think the world recognizes that hang drying the laundry is a really, it's a funny on the one hand, but a really powerful solar technology, is the amount of energy that we're spending on dryers. And we're going to have, put this before Christopher as well. But if we're at that 8% level, 8% of the average home's, electricity usage going towards the dryer, and, the average, if we look at the entire pie of electricity, about a third of it goes to homes, third goes to like industry and then commercial. But if a third is going to homes and 8% of that third is going towards the dryer, then you're at something like 3% of all of our electricity in the US is going just to power our dryers. And how do we conceptualize that? Solar energy is just top 3%. So all the hundreds of millions of solar panels that we've installed in the US, and solar is growing so fast and we're promoting that, is right around 3%. And yet, if you think about it, solar panels are kind of ostensibly just powering our dryers right now. We could double our solar energy if we, did like a lot of the world, like Italy, and hang dried our laundry or got more efficient dryers, like Christopher was talking about. Another way to look at that, 3% of electricity is something equivalent to like 40 plus coal plants. Now, coal's going bye-bye, and we're excited about that, but that's just a way the faster we can kill coal, the better. So beyond energy and culture, there's also savings. In the US, like Christopher said, there's not huge monetary savings. You're at like $100 to $200 per family saving if you hang dry all your laundry. If you're, you don't have access to a washer and dryer in your home, it's going to be more expensive, and you're going to be paying more to dry your clothes. And so you could have significant savings, $500 plus. The other thing to note on that is, in Europe and in other parts of the world, that they're paying, double, triple what we're paying for electricity. So their savings are more substantial. And one other point I just wanted to highlight why folks love hang drying laundry is something that people my age and younger may not have experienced: the line dried laundry smell. If you've ever had been lucky enough to like lay on sheets that you've dried outside, like we're doing right behind me, it's just amazing. And I was put in touch with this Italian researcher who actually did a study as to why that happened. And she was in the New York Times. I'll put her link in. And really, it's complicated, but the UV rays of the sunlight are interacting with the water molecules on your clothes to form these delicious scents and odors that are only produced in line drying clothes, was their findings. Odors of like citrus, cardamom, and rose. And so, I would highly recommend folks who have not experienced that to go out and hang dry some laundry ASAP and then just smell it afterwards. It's just it's an amazing experience, worth the 8 extra minutes it takes you to hang dry laundry just for that. Okay, so there's some reasons I think the world is hang drying. There's others. Some tips to do it quickly. Get a front load washer, as Christopher said. It just wrings out more water. And of course, wash in cold water. We've talked about that today. Just a no-brainer, easily done. Another thing that I discovered late in my hang drying journey is, if you don't want a crunchy towel or a big object, shake it before you hang dry it. You won't get as fluffy as the conventional dryer, but it will make it less crunchy as far as towels go. Drying inside, again, most of the world, even northern climates, are drying inside all the time. You want to dry laundry on a rack, easily done. Get it out of the way so you don't look at your laundry all the time. Put it near a heating source. Mine sits under my ductless heat pump and gets dried, but totally doable as well indoors. Use clothespins for faster drying. That exposes more of the clothes to the sunlight and the wind. They dry in no time. And then let's just look at a couple hang drying technologies. I love using the word technology around this stuff. It's simple, but we don't have it in our culture. Hang drying racks, $20 to $50, easily bought at lots of stores or online. The horizontal rack works great. The vertical rack, I love. You can get just a ton of little items on that. They fold up, are storable. You can use them indoors, outdoors, really versatile. Clotheslines, can't say enough about this original technology. This was from a recent trip we took to Cleveland. My grandpa had an old laundry line that hadn't been used in decades, and we fit 4 loads of laundry on that line right there. And 4 loads of laundry, if you're talking 4 to 5 kilowatt hours a load, you're at like 20 kilowatt hours right there. My electric car can go 80 to 100 miles on that laundry right there. So that's real energy that you're saving for the other uses that are a little more important. So here are the 5 clotheslines, retractable line. Behind me, you'll see the laundry umbrella. Great, I can get about 2 loads of laundry on this guy right here. Really versatile. I take it out of my patio table and then put on the laundry umbrella. Works great. And then there's the pulley systems. I don't have one of these, but I think they're super cool. You can do an outdoor pulley system or indoor, get your laundry out of the way. And then one final technology is these clip hangers. They work great. You can look at all these slippers on the picture. You can hang dry a lot of small objects with these great clip hangers. So again, let's sum up the why laundry and get to a little more Q&A. We're looking to use electricity well. Dryers use 8 to 10% of electricity. Heat pump dryers can save you up to 60% of that load, so easily done. Wash in cold water, it saves you a ton of energy. And then hang drying is such an easy way to save laundry that most of the world is doing. So we should think about. So with that, I'll say thank you. I'll stop sharing my screen, and I think we can finish out the hour with a little more discussion.
Thanks, Joe. Actually, for both of you, this I was just sitting through the PGE IRP planning, which is basically where they're talking about, the projecting the future loads. And back to a point that Joe made early in this presentation, the electrification of buildings and transportation is going to really increase the amount of energy we need. But it's interesting that a lot of these technologies we're just talking about are a really important part of the solution. It's not lost on people like PGE that these efficient appliances really are going to help offset some of these loads that are going to come that are increased. So I just want to reinforce that point, because that whole idea about efficiency is really a really important part of the electrification challenge. Pramod or Joe, did you see any questions in the chat that we maybe haven't got to today yet so far? Yeah, I saw one about killing germs and whether a conventional heat pump, a conventional dryer at high heat does a better job of killing germs or disinfecting than a heat pump dryer would. Is there anything to that?
Yeah, a conventional dryer doesn't get all that hot. I mean, it's not hot enough to kill germs. It's still in the kind of below 100 degrees kind of range, maybe 100 degrees. It's not hot enough to actually kill germs, but it's not also hot enough to actually do much damage to your clothing. It's a pretty mild temperature.
I mean, I saw PGE has some really good videos and things on washing particular, and they're talking more about cold water washing, and they did some good work to just sort of debunk the germs thing with washing in hot water. There wasn't a lot to that. So basically they do a lot of work to just show you why it's so much better to wash in cold water. It's just, I think it's more of a cultural habit we have, that we have this impression that things are getting cleaner in warm water, but it's just not really true.
Yeah, I do want to highlight that comment from Loria, that sunlight is a great disinfectant, right? UV rays, we've seen that in the age of COVID. Yeah, what a great disinfectant to use those UV rays behind me to clean your clothes.
Joe, what about, are there city regulations prohibiting clotheslines and that sort of thing that you're aware of? I mean, is that a thing?
Yeah, there's a lot of folks, who work on that. A lot of HOAs prohibit clotheslines, which is unfortunate. And, there are folks like Eli Spivak, our good friend, who work to, legalize clotheslines everywhere. I think it's great to take that fight forward. Also, I think the drying racks work great if you need to be a little bit more conspicuous than I am being today. And drying racks, you can just be kind of out of the way and just dry and not have to take on that fight. But there are some HOA rules, and if you need some help in fighting them, please let me know, and I'll work with you.
Christopher, do you have any information about front load machines, washing machines? This is the question, leaking. I certainly have never had that problem, but is that something that you've heard about? I've never heard of that.
No, I haven't heard that. I have heard that the rubber gasket seal on a front loader can get a little ripe if you close your machine. And then that was just sort of something that I've learned over the years, that a front loader, you should leave the door open after you've used the cycle, so that that little pocket of water that sort of sits down in that seal, if you will, has the time to dry.
Yeah, that's what we do in our house. We just leave it open in it to keep it from getting funky. Yeah. We had a technical question from our friend Karina about refrigerant loss. And have you ever looked into that for these devices, for heat pump dryers? Or
so they're required to be disposed of like a refrigerator, which means they have to have the refrigerant recovered. I'm not sure that our recycling shops and such are familiar with the fact that a closed dryer might show up and it has refrigerant in it. Mm-hmm. So that might be something that's just sort of general awareness hasn't reached yet. There's not a whole lot of refrigerant in them. They have I'm trying to think of just how much it's very, very small. It's a very small refrigeration cycle. It's smaller than a room air conditioner for sure.
It would seem like the likelihood of a leak would be relatively low because you're not, unlike some other systems, you're not pushing refrigerant from one area to another. It's all right there in the condenser, right? I mean, it's not like you have to hook up a refrigerant line and pump it across the house or something like that.
Yeah, it's all done within the factory. And so it's all kind of within that space. But of course, everything can have the potential to fail at some point. But, refrigerators, this is the same technology that we've used in refrigerators, they'll last 30, 40 years. The refrigeration cycle is extremely robust. More likely, things like buttons and switches and other elements will fade out and fail long before the refrigerant line fails. It's copper and aluminum.
It's a great point. And I did want to just, and I know we're coming up on time here, just give a quick shout out to our partners in Hang Dry Week, African American Alliance for Homeownership and Solar Oregon. We thank both organizations a ton for joining with us.
Yeah, in terms of what refrigerant, I see a question in there. I'm trying to think of what they're using in Europe. I think they're going to not propane R600, but or that's 290.
R32, are they moving to R32?
I think it's 134. They need a higher temperature refrigerant. Yeah, and that's also a pretty high GWP kind of element. I don't actually know. 32 is a fairly likely one that they'll switch to, which is about a quarter of the GWP.
Mm-hmm. Great. Well, any last thoughts, Joe, before we wrap up here?
I think this is probably my dream come true webinar. I've been such a nerd about hang drying laundry for so long, but to be able to share it with folks has been super fun, and to be able to share the stage with Christopher Diamond and all his great knowledge. So thank you a ton, Christopher, for being on today and
You're most welcome
this week.
Yeah, and I just want to say that, having had heat pump dryer for basically 8 years, we'd never found any element that led us to regret that choice. It was a good choice.
It's so funny, isn't it? How well, I'm glad to hear that, and it's a reminder that these things that seem new to us have been common in many parts of the world for decades. And so it's just more a question in some case of us getting acclimated to that as being a really normal thing, instead of it feeling like it's some like spaceship new technology, because it's really not. The same is true with water heaters and heat pumps in general. But yeah, so that's a good perspective. It sounds like you've had some real world experience with it. I know Joe's jonesing to get one.
Oh yeah, definitely buying one soon.
Absolutely. Yeah. All right. Well, thanks everybody. And as always, we really appreciate your time, and good luck with your electrification projects. And if you have any questions about anything you're doing or need more information, please feel free to reach out to us. We try to be responsive and love helping people when we can, and potentially hooking you up to some good resources. We will be sending an email out to everyone with links to the presentations, the recording, and if there's some of this other supplemental information that we've discussed, we might include that in the email as well, if we can dig up some good other references for you.
And Brian, before we get off real quick, Pramod, could you remind us again what Hang Dry Week is all about, what folks need to do?
Sure. Yeah, like Joe said, follow us on Instagram. Our username is Hang Dry Week, and to participate, in order to maybe win some prizes, make sure you post a picture of your laundry and use the hashtag Hang Dry Week, and we'll get to you soon if you win a prize.
Thanks everybody.
Thanks so much, y'all. Thanks, Christopher.
Thanks, Christopher.
Bye-bye.